Good morning, and today we will be looking at the scalar product. The scalar product of two vectors a and b is defined as, and I'm going to give you a formula for that, and this formula is on the formula list. Now a dot b is the way we write the scalar product, okay, and it comes from multiplying the vectors together. So we multiply the magnitude of vector A and magnitude of vector B together, and we multiply that by the cos of the angle. It's on the formula list. The angle is the angle between the two vectors A and B. We sometimes call this the dot product because we do call it A dot B. That's what we call it for the scalar product. The scalar product and the dot product are the same thing. Now, this is a particularly useful formula for being able to find the angle. We can rearrange this eventually. I'll show you that in another lesson and how we rearrange this to find what the angle is between the vectors. And remember, knowing the angle between vectors is extremely important because a vector is all about size as well as direction, isn't it? So it's really important that we can work out the angle between vectors to give us that direction. Okay, this is very, very important. I want to stress this here. Look at the angle that's drawn in this diagram and look at the direction of both vector A and B. Both of the vectors are pointing away from the angle. And sometimes you have to rearrange the position of the vectors to be able to get them to both point away from the vertex. So if they're not already pointing away, you have to reposition them yourself. Okay? And just remember that a scalar product is just a number. You're going to get a number for your answer. It is not a vector, it is just a scalar, which is a number. Okay, let's have a look at an example then. Two vectors A and B have magnitude 7 and 3 and are at an angle of 60 degrees to each other as shown. Let's just check what the diagram looks like. Now look at the diagram. I can see we've got our vector A and our vector B. I'm quite satisfied that both of those vectors are pointing away from that vertex that's marked as 60 degrees. Okay, so what is the value of A and B? So very simply, we're going to use the formula that we've been given. This formula, once again, is on the formula list. So the scalar product A dot B is equal to the magnitude of A, and we've been given the magnitude of A, and the magnitude of B, and we've been given the angle. So it's just a matter of substituting it in. 7 times 3 times the cos of 60. Okay? 7 times 3 is 21. Cos of 60 is 1/2. Now at this stage, you will be able to use your calculator. We haven't covered exact values within the course yet. If you had covered exact values, you would be expected to work out the cos of 60 without a calculator. But we haven't done that as yet, so don't worry. Okay, you can just put that into your calculator. Okay, so the answer is 21/2. Okay. Here we have a different question. A and B this time have magnitude 7 and 3. The angle is 90. Okay, so the angle between the two vectors is 90 this time. All right, so we've got our magnitude 7 and 3, and we have got an angle of 90. So 7 times 3 times the cos of 90. Now think about the cos graph. At x equals 90, that's where the cos graph crosses the x-axis, isn't it? Okay, so the cos of 90, we know from the graph, the cos of 90 is 0. Now you know that from National 5. So as soon as you get a 90-degree angle in there, your answer for A dot B is going to be equal to 0. Okay, now remember 90 degrees means that the angles, the two vectors are perpendicular to each other. So we'll come back to that later on, but we've just really shown there that whenever we have an angle of 90 degrees, the scalar product is 0. If we knew the scalar product was 0, that could be a way of proving that the two vectors are perpendicular, and we'll come back to that later on. Okay, here's one that's a little bit more of a problem involved in it. Vector u has magnitude k, and v is twice as long as u. So u has a size k. So I'm making it a bit more complicated by not giving you just numbers this time. Okay. The angle between u and v is 30 degrees. find an expression for u dot v in terms of k. So we know that the magnitude of u is k. Okay. We know that the magnitude of u has been given and v is twice as long. Okay. But look at the direction that the vectors are going in. They're not both pointing away from that angle 30. So we have to change the position of the vector. All right. Now remember, a vector is just a line that has size and direction. It doesn't have to start at the fixed point there. And that doesn't have to start at the fixed point there. So I could actually think of lifting that vector, for example. If I place that vector into that position there, that's fine. And that means that they would both be pointing away from each other. But then instead of an angle of 30, the angle would be would be 150. So I'll show you that in a diagram here. Okay. So instead of the vectors being in that position there, we just move the vector u from there to there, lift it and move it to there. But because that's now a straight line that has created, those two angles there are 180 when they're added together. So 180 minus 30 leaves you with a 50. So the actual angle that we're going to be using here is 50 when they're both pointing away from the vertex. So be very, very careful when you have to move the position of vectors in order to get them in the right place, pointing away from the vertex. So we're going to be using the magnitude k, the magnitude for u is k, the magnitude for v is double that, so it will be 2k, and the angle is not 30, it will be 150. So that's the actual diagram that we're going to be using. Okay, so the magnitude of u is k, and the magnitude of v is double that, which is 2k. Don't be confused that we're using letters. They haven't given us numbers, so we can't put numbers in here. And it's the cos of 150. Now again, if you had done exact values, you would be doing this without a calculator, which is what you will eventually have to do for these types of questions in the exam. But at this stage, just use a calculator. Okay, so 2k times 2k is just 2k squared. And the cos of 150 is minus root 3 over 2. Now, if you get a decimal equivalent of that at this stage, because you are allowed to use a calculator, that's fine. So if you see an answer that has got surds and fractions in the answer, and your answer is a decimal, just do the divide of the fraction and check that it equals the decimal that you have. At this stage, because you haven't done exact values, we will accept that answer. And then just put it all together. So we have got a positive times a negative, okay? And then we've got 2 at the front, so a negative overall, then the k squared, then the root 3 at the top, and on the bottom, remember that's just an invisible over 1 there. So that's the top times the top, and that's the bottom, which is a 1 times a 2, so the denominator is just a 2. Okay. Now those 2's cancel out, there and there. So we're just left with, and I always like to put the number before the letter, so we're left with a negative, the root 3 first, then the k squared, and the 2's have cancelled out. Okay, now I'm going to show you a different version of the scalar product. So the scalar product is a dot b. If we're given the angle, then we use the first version that I gave you. But what if we're given the vectors in component form, like this? So if we've got vector A is A1, A2, A3, vector B is B1, B2, B3, then what we're going to do to get the scalar product from in this format is very simply multiply the two vectors together. Okay, so the scalar product is found by multiplying the two vectors together. Now you do that by multiplying each component one part at a time. So we're multiplying A1 times A2, so the two top numbers, plus A2 times B2, the two bottom numbers, A1 times B1 plus A2 times B2 plus A3 times B3. Okay, and that gives you that. And this is a very simple thing to do. So it's another version of being able to find the scalar product, depending on the information you've been given. And that's another thing that's on the formula list. You will see that also on the formula list. So both versions of the A dot B, the scalar product, are given on the formula list. Okay, very simple example to finish. So if I give you vector P and Q here, find P dot Q, find the scalar product for P and Q. So we know this is given in the formula. You don't have to write it out like that. You can go straight to the numbers if you wish, but that's given like that. Okay, so we're going to multiply the two tops, 2 times 1. Then we're going on to the two middles, plus 4 times negative 3. Then on to the two bottom numbers, plus 4 times 6, 6 times 4. Put those together. So there's your 2, there's your negative 12, and there's your 24. Put all of that together, and that gives you 14. Okay, so the scalar product of vector P and vector Q is the number. Remember, it is a scalar, so it's a scalar product. I think in a sense this one makes more sense to the wording of it. Scalar product, a numerical number that you get when you find a product. A product is to multiply things together. So it's the product of the two vectors. Okay, so we have 2 exercises here. I'll give you a bit longer to do that this week. So exercise 13O, the selection of questions given there, and then exercise 13P, and we have the selection of questions given there. And as always, if you have any questions at all, just don't hesitate to ask your teacher for help and send in a photograph of your marked work so we can give you some feedback. And good luck and take care.